Hey guys, your boy Chili here. Welcome back to Chili's C++ Repentance Tour. In the last video, we did a bunch of stuff kind of setting up projects and solutions and project templates and shrimp gumbo, butterfly shrimp, garlic shrimp, you know what I'm saying, all that stuff. But it culminated in pulling in CLI 11 with vcpkg and, playing around with that a little bit, seeing, oh, here's a cool third-party dependency you could pull in and use. Now, this was all foreplay for my ultimate plan of messing around with CLI 11, seeing how we can make it better. So what's my beef? What is Chili's beef with CLI? Well, so you gotta define some data members. I like to organize them all together in a struct here. It's very, very organized. It's not necessary, but it's nice. So you define the variables that the CLI parameters or arguments are going to go into and that you can access from the rest of your code. You define the variables, you can give them default values if they aren't, modified by whatever's passed in on the command line. But then after that, after you define this, then you have to hook it up into the CLI app, give them, the switches that they'll be associated with, and maybe give them a description, right? And there's other things you can do, but we'll get into that later. Now, my beef is that I don't like that you have to do these two things separately. This leads itself to a very common issue where, let's say you've got a big project, lots of complicated moving parts. You want to add an option to the command line. Someone dives into the code, they find the options struct, and they're like, all right, std string butt plugs is equal to, of course. And they're like, good, I got a new option, it's got a default value, let's rock and roll. And that'll compile and everything, and it won't work because it's not hooked up in here. But you didn't see it or you forgot it. Your mind was busy. You were looking at your second monitor. I don't know what you were doing. But inherently, the problem here is that there's two places where information is kind of duplicated, and you've got to keep them both in sync. And I don't like in sync. I don't like boy bands. So how do we solve the problem? Well, here's what I want. Let me tell you what I want. This is what Chili's wish list is. So I want to be able to have a special struct in here like we have. But when you want to add an option, you don't just add a string or an int. You add option templated on whatever you want it to be. And then you get the name of the option, my opt. And then you pass in some parameters like my opt as the name, and then you don't have to pass in what it's bound to because that is automatically this thing. And then when you want to use it, you just use it like you use the other ones. You just do, opts.myopt, and it all works. And you don't need this because it's automatically constructing an option, is initializing it, is hooking it into the system, is all the things. One definition, single source of truth, and that is what I'm all about. So how do we do it, though? That's the question. We know what we want, but how do we get there? Right, well, I think there's probably a few ways that you could go about this, a few different approaches. One wouldn't even require this, templated option object class. You could probably just do it with X macros. X macros are they're a way of reducing duplication of code and creating a single source of truth, but they're also macros, and macros are grody. So I like this I like this idea of having a templated option class. Now, the way that we could hook that up to app is we could make app like a global or singleton, and then the hooking up would just be globally. Or we could make our struct encapsulate the app, and then we pass in, this when we're creating this thing to hook it up to the app object, which I think I'm going to go with for this one. But I've actually tried the other one in previous incarnations of this idea. So that means we need a class. Now I'm basically just making this shit up as I go along, so we could very well crash and burn, hit a brick wall, and if that happens, then I don't know, we'll figure something out. So I definitely want CLI app. That's the app. I actually think that's it for now. Then we have to construct the option base. I'll add things as I actually need them. So we're going to need option base. Then we're going to need a class option. I'm going to call it options base because this is the container of options as opposed to this thing, which is a specific option, but whatever. So option is going to need a pointer to its parent. Very important. And we need a constructor. And we'll keep it simple for right now. We need std string names of the option, the actual things that you use on the command line, and std string description. Now, as I mentioned, this has to be templated, so we're going to do a type name t on that bad boy. And then we're going to have to encapsulate the actual data of the t. So t data. So we keep this in here, names, description. Let's put in here t and default value. So you're going to have to provide a default value for every one of these and a description. And if you want to flesh it out, you can make these things optional by making different versions of the constructor or making some default values, but we won't worry about those kind of issues. We're just going to get a base thing down here. Now, when you call add option on app, you actually get back a pointer to a CLI option. And we would like to retain that in our option object. So we're going to go CLI option pointer to p option is equal to null pointer. And what we're doing in our constructor here is very simple. Wait a minute. I messed up. I need an options base pointer to p base. This is overlapping with this, so we should make these, we'll just put an underscore after them for notation of privateness and to disambiguate with parameters coming in. Now we could be, fastidious here, and we could create an interface functions in options base that, expose the functions on app, like for example, add option. Or we could be like super lazy, which is what I'm going to do right now, and just do template, type name t, friend, class. So we're going to make all template instantiations of option to be friends of option base, and then we can do p parent underscore pointer to app underscore dot add option. All right, so now when we construct an option, we're going to add it to the parent. I'm going to retain the pointer that is returned. Give me this. What do we got here? So you need the option name, which is just did move names. Don't do that in there. I don't think. Close that. There we go. We need the thing that we're going to bind to, which is data. And we need the description, which is did move description. Now, here's the thing though. So we're going to put this in a struct like this, but we want to actually access the data here. So we're going to need a way of doing that. And a nice way of doing that sort of thing, sort of idiomatic way, is we could do, let me see here. We only want to read it. We don't want to be able to write to the command line options. Command line options are written to by the person invoking the application, right? So you don't want the application itself to start writing to them. Maybe you do, but I don't. And I'm the guy making it, so there you go. Operator. So we do the dereferencing operator here. And we can make that const, because we're not planning on it modifying anything in this object here. And we just want to return data. So we allow you to get at the data with the star. Now, another thing that we might want to be able to do is we might want to be able to tell whether something has been passed on the command line. Like each one of these, you can access its value, but you don't know if that value was the default or if it was modified by somebody passing something in. So I would like to query whether something was present in the command line. So let's do bool, and let's just use Boolean. So whenever you treat this option object like a Boolean, you are querying its presence. And that's very common. That like std optional, which interestingly enough shares almost the same name, also works similarly to that. So operator, bool, const, and what are we going to do? Well, we're going to cast to bool p option, because that's actually how p option itself works. Or not p option, CLI option. It just works like if you access it as a bool, you get the information about the presence of the option. And let's add another operator while we're at it. Bool operator, the not operator, because that's fairly commonly used to also check the presence. And we're just going to return not bool this. So we're going to, chain onto this implementation. Now, the only other thing is we have to actually create the app itself. So we create the constructor of options base, and it should take in int argc and car pointer to pointer argv. Now, right away, I'm running into an issue that says maybe I can't make the thing exactly the way I want to make it. So what's my problem? Well, I want to create an options base, and this holds the app object, and it also holds the logic for, registering the app, parsing the command line information. And then what you would do is you would have, like struct my opts public options base. So you would inherit from options base, and in here you would add your options. So you'd be like, okay, option int by int option, and then you would put in here this pointer to the parent, and the name's my int, and a default value, which is of course this, and the description, which is disk. And there you go. You would have your option, and when this is constructed, it is gonna, it's gonna invoke the constructor of this, which is going to register on the app. Now, there's a problem with this. So if I make this constructor be the thing that actually parses the command line, let's take a look here. So the command line 11 parse is just app.parse argc argv. So in here, I would just want to do app underscore dot parse argc argv, and there you go. Now there's a problem with this. In the order of construction, when I construct a myOps, what it's going to do is it's first going to call the constructor of the base class, and it is going to call parse even before it initializes the members of myOps. So it's going to parse the command line before I had a chance to register my int option, and that kind of sucks. So what I would need to do is like maybe, put like a parse function in here, and then the person, when you make myOps, you'd have to make a myOps constructor, and in there, call parse. Now that sucks, because I wanted all the boilerplate, all the stuff that you always have to do. I want to push that all up into a different layer up here in the base, and then I can just define my options in this struct. I define the minimal stuff, and everything else, all the boilerplate, is taken care of by the parent, right? That's what I would like to do. But as you probably are aware, we can't have nice things. Or can we? Well, we can if we get a little devious. We do a little lazy evaluation. So what we're gonna do is, and there might be some issues with this, but we're gonna cache. We're gonna remember argc and argv. We're gonna create a little funky wonky in here called finalize, only accessible by privileged people. And in here, we are actually going to do ya boy. You might say, well, this doesn't look much different than what you were proposing before, Chili. Well, let's do a little more. We're going to do bool finalized is equal to false. And then if not finalized, do the parsing. So here's my idea. And I don't think I'm going to use it, but I'll tell you about it anyways because it was kind of neat. It was fun while it lasted. So we put this function here, finalize, and whenever you call it, if it hasn't been already called, it is going to parse. That's cool. Where do we call it from? Anytime any one of the options is accessed to either, get its value or get its presence information, we always call finalize. And this will ensure that the data is finalized before it is accessed, but after everything has been registered, by deferring it, by lazy processing of this parse. Now that's cool and that would work, except that app parse can throw an exception for a number of reasons, because the command line was bad or because the user requested the help option that would signal that you should exit early. And I don't want that exception to come out just when someone is, trying to access an option for the first time, right? That exception should be coming out in a place where we are in a good position to handle it. Like at the startup of the program is when we would probably want to bail out early if the user just requested help option, for example. So that is why that this neat idea, I don't like it. But I do think that just adding a finalize, that'll be fine, and we'll wrap it up nicely so it's not too bad. All right, now I want another class-like option. And this one is for flags, because flags are a little simpler. They have a different interface, so we should use a different class for them. First of all, they don't need to be templated, because they're always just bool. So we'll go flag. It still takes a pointer to the base, still has a name, bool default value, and string description. So that's fine. Now the data is always going to be a bool, and you can pipe that into there. What else? P parent. Now even when you create a flag with the, I don't know what the function is. Create flag. Add flag, it's going to return P option. So it's still an option object in CLI 11, but whatever. Maybe I should just make flags act like bools, and we'll forget about presence information. Presence information is the value, in which case default doesn't make any sense because default is just not present, right? So in that case, we get rid of this, and we don't even really need the data then, do we? I wonder if what's the deal with flag? Add flag, flag name, function, flag name, and flag description. So we could just call it with a flag and description. We don't even need the binding data. Although it doesn't like this one. I think it needs a reference. I see the problem here. I see the problem. We're not friendly enough. Also, this is not a template class, so we can just do it like this. There. How do you like them apples? Like that? How about you? Seems good. So now we don't actually have to create a boolean in here and bind it. So there we can add flags, we can add options. So let's do, let me include optional, just to make things extra confusing for us. So I want a function that basically does all the stuff with my opts. So we're going to create a template class O for opts. It's going to be a function that returns a std optional int. And this is error code if an error occurred. So this is a function to initialize the optional. I'm getting ahead of myself. The init function, let's do my opts and the const get opts static. So here we create the singleton. my opts. Whether you want to make this as a singleton, it depends on you, I guess, but it's convenient if it isn't an issue. Opts return opts. That should be fine. And then in init, we're going to call get opts dot finalize argc argv. I'm going to put that in a try catch. See what we're supposed to be catching here. CLI parse error. I'm a little unhappy about the encapsulation here, but we can worry about that later. So because init is not going to have access to the actual app object, we need to expose app.exit, giving it the error code. I'm going to return the return code that exit provides us with. And then we can return auto opts is equal to get opts. And then we're going to try opts.finalize. If we don't have it, we're going to go opts.exit. There we go. Okay, so there's work to be done here, but we got a first draft down. We just want to check. We just want to try some stuff out first here. So get rid of that. Auto error code is equal to init argc argv. So if we have an error code, return that error code. Otherwise, we can have some fun. We can do auto and we can do const opts is equal to get opts. So we get the singleton, we give ourselves a little shortcut for it. And then in here, we just want to check a couple things. We want to do ops dot option one and ops dot flag one. All right, so let's build it, see if it shits the bed. Looks like we got a little bit of bed. I almost feel like just to make things, equivalent, we should just make this one return bool this. Bool. So operator star for this one returns a bool. And then we can just do star for this one, star for that one, and everyone's happy. It's better to make the interface uniform. All right, now we run it. I have a very small issue here, just a minor issue that we don't actually set the p parent, which is not good. Now technically, because we're only using it in the constructor and never after, so as long as we don't need it, I'm not even going to store it. So p parent underscore from here, p parent underscore from here, and we're going to use just the one that's passed in because we weren't initializing that, and that was causing a little bit of an issue, just a tiny wee issue of, trying to access a null pointer. All right, run it. Okay, I have a little bit of a trepidation here regarding add flag. So this constructor here that takes a t and flag description, data is equal to false. So it's always defaulted to false. And then we're just going to go data and description. And now, because we did this one, I can satisfy my move RAII OCD. Do that. These can all stay the same. We don't even need to really reference this. We just put it in there because we need something to put in this constructor here. All right, let's go. There we go. So option 1, 420. That is what we put in here. Flag 1 is true. And if we turn this off, false. Okay, and if we turn this one off, we should just get all the defaults. 69 and false. And we can also check our presence checking. To do that, we go opts, option 1, and we want to convert that to a bool. Now we're checking to see whether it's the default value or whether it was overridden from the command line. So option 1, We should probably do a did endl there. Option was present, false. So it has a value, which is the default value, and we can tell that it was the default because it was not present. But if we give it an actual value and we run again, we can see the option was present. All right, now there's a couple things that we want to clean up here and a couple things we want to add before we wrap things up. So I want to clean up the way that we initialize and we get the options. And I also want to add the ability to set the application name and to set the application description like we were before. So the way we're going to do both of those things is a little something called curiously recurring template something. CRTP pattern, I guess. So we're going to template the base and we're going to use information from here to get the app stuff. So the app description is going to be T description T. We won't worry about the app name because it picks that up automatically. So we won't. You could put it in if you wanted to, but we're not going to. So we're just going to do T description to pick that up in there. But now we require argument list for class template options base. So we actually need another layer here. We have to go deeper. We're not going to template this one. We're not going to initialize it here. We're going to call this one options container. Then we're going to do template class T class options base. This is the one that we inherit from to create our actual options. And this one is to protected so that the child has access to it. Options container. The only thing we're going to do in here, options base, we're going to make a constructor that initializes app. No, we need a constructor in here, options container. We'll type in const car pointer to description. Use that to initialize app. Now the base, which is templated, is going to pick up that template parameter T description. Pass that on into here to construct this guy. Okay. And then option is going to have pointers to option container. So it doesn't need a template parameter. And then myops is going to inherit from options base with its own type, templated on its own type. That's the recurring template. But now we need this pointer, inaccessible base class. That's easy. That's just me forgetting the public here. And now in here, all we have to do is const expr const car pointer to description is equal to nutty fun happy static const expr. There we go. So now you can tag your options with this description and it'll get picked up and fed into here in the machinery. Probably helps if you spell it right. There you go, and here it is. Nutty fun happy CLI usage, blah 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 blah. Actually, this is way too long. Like I don't want this whole path in here. So we're gonna make the options container constructor take in description and name, and options base is gonna pick up those two from its template parameter. And then here we just gotta add name, which is, of course, Jennifer Connolly. 2 N's, 2 L's, because you probably don't want the space in here, huh? Now we get the usage, Jennifer Connolly options, and options are all these things. Okay, beautiful. So there you go. So now we can, when we create our actual, because the idea is you keep all this stuff as your framework of CLI in a separate project or whatever, in a separate library that you can just use in all your different projects. So we want to push as much boilerplate up into here as possible. And then the thing that you do every time you make a new CLI, you want to make that as lean as possible. So here you only define the options, the flags, and the strings that get picked up statically. Now, while we're at it, let's clean up these init and get ops and put it in somewhere a little more savory. So what we're going to do is we're actually going to put them in here in the template base, because that's the place for them. That's the place where fresh is the taste. Static init. Probably helps to have a return value there. Static void get. That's not void. This should return, and you might think it returns itself, but it returns t, the thing that it's templated on. So you want to return a static. I would like to say const t. This will work. Trust me. Trust me. I'm sure this is probably not illegal, but mostly when the client is getting something, they want a non-const one. The only time, or they want a const one, they're only reading. The only time we don't want to read is when we're initializing. So we're going to do some hanky-panky, but let's go get. Get is just going to be, you make a static t opts, and then you return opts. Create your, your static singleton instance in here that you get every time you call. First time you call, you create it. Every time after that one, you get the same one. Okay, now for init. So what does init look like? We gotta steal this basically. It's gonna return optional int, which is the return code, and opts is going to be equal not to get ops, because get ops is now toast. Get out of here. The new hotness is in here. So init is going to call get, but we're going to do the cast I almost never use, const cast t and. So although this one actually returns a const reference, in this special case we want a non-const one, so we're going to do a little hanky-panky. I mean, there's probably other ways I could do this. Let me think here. Yeah, so here's a way that avoids using the const cast. So we make a getter, a private static getter that returns a non-const t. Then the public one returns a const t. So we just feed into the private one. And this just removes the ability to modify it. And then in here, we can call the private one. And then we can call finalize because it's not const. Call my opts init and my opts get. And there you go. That's cleaner. That is nicer. And then to define a whole new, set of command line options, you just inherit from options base, pass yourself as the template parameter, and then you add your options, you add your flags, hide your kids, hide your wife, hide your dog, because you know the rest. Now we could do a lot of things to make it fancier, but I think this video is, even after I edit it, it's going to be longer than I want. So like after you create an option, you can do stuff with it. What kind of stuff? So you can say excludes, and you can pass in a pointer to another option. And what that'll do is that'll say, okay, these two options are now incompatible. If you supply both of them at the same time, that's an error. And it will validate that. Or you could make an option mandatory, saying that this option, if it's not supplied, the program won't work. Or you can make an option needs, so this option can only be supplied if a different option is already present. That sort of thing. You can add a whole bunch of different constraints and validation things into here. But with our interface right now, we don't have a way of doing that. Now, the way I would do it, I would make the constructor for option and flag optionally take in a lambda function. And that lambda function has the signature that it takes in a CLI option, reference to a CLI option. And then, so if you pass in a lambda, it will call that lambda with the option after it's been created, and you can customize the option via your lambda. So that is how I would do that, and that's actually how I've done it in the past. But this video is getting long, so I'm not going to do that. I'm just going to leave it at this. Well, we'll do one more thing. We'll clean things up a little bit to show you how I would actually do this. All right, so here's how I would organize all this happy crappy. So I'd put all the framework for CLI in, its own static library, its own files here. You got header and source separation. And, you have your options container, the templated intermediate that you derive from, the option, and the flag. I move, a lot of functions into this one, but you can't move. There's many you can't move because they are part of template classes, so they just got to chill out in the header. But you push all that stuff into this central thing that can be used, in different projects in the same solution and can be pulled into different solutions. And then in every project that, builds an executable that wants to parse and understand the CLI options, you would add just a header file, options.h. You would include the framework header, and then you would define your own options struct based on, the options based. And you would add all the options that you want. You would tag your description and name. And then in your app itself, you just call init, and you call get with your options, and then you can just use options like that. I like instead of calling options get every time, I like to create myself a little shorthand using const auto, or this could actually just be auto because it returns const. Get does. So there you have it. That is how I would, organize. And like I said, lots of things that you could add to this. For example, we're going to end the video here. Hope you enjoyed it. If you did, please click the like button. Helps a lot. And I will see you again with some more C++ repentance.